Welcome to today's mathematics lesson. My name is Rosen Timunya. This lesson is proudly brought to you by the Gauteng Department of Education. Right, today we're going to have a very active lesson. So I'm going to ask you that you make sure you've got a ruler and a pencil, and you will be drawing quite a lot of diagrams today, okay? Right, so you need to also save our WhatsApp line 0635081301. If you have questions, if you feel like you need input here and there, let me know, because today's lesson is about investigating. So we may have questions. When you investigate something, you ask questions and seek answers, right? So today's lesson, we are going to be investigating the minimum conditions for congruence in a triangle, right? Okay, let's look at our lesson objective. By the end of this lesson, you should be able to establish the minimum conditions for congruent triangles through investigation, all right? And then if we have time, we'll do an activity so that you can identify some of the minimum conditions that are required for triangles to be congruent. Okay, all right. Then for pre-knowledge, you need your knowledge of congruent shapes. You still need your understanding of triangles. Constructions, these will definitely be needed today. Your understanding of that section is going to come handy today. Right, your baseline assessment is based on stuff we've worked on before. It says in the given figure, ADC is a straight line segment, BD is equal to DC, and angle B is equal to 25 degrees. Calculate the size of D1. I'm going to give you 3 minutes to answer this question, and then we'll discuss the solutions. Okay, class. So here, what you should have started with was to make sure you read the given information and then ensure that that information is reflected on your diagram. Okay, so you were told that ADC is a straight line, so that means one of the sides has been extended in this triangle, and you know, as soon as you see that a side has been extended, there will be an exterior angle to the triangle, right? Then you're told BD is equal to DC. Is that shown on the diagram? No. So that's the next thing you need to show. BD is equal to DC. Now, what type of triangle to get between on BDC? You now have an isosceles triangle, okay? Right, and then you're told that angle B is 25 degrees. So if you fill in the 25 degrees for angle B, what other angle is going to be 25 degrees? It will be angle C, right? Angle C will also be 25 degrees, and you can write this down as well. C is equal to 25 degrees, and then you'll say angles opposite equal sides, right? Then you were asked to calculate the size of D1. So D1 is an exterior angle there, right? Now we know that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Therefore, when we add angle B plus angle C, we get the value of angle D1, right? So that means you are going to get D1 to be equal to 50 degrees. You add 25 degrees for angle B and 25 degrees for angle C, and you get 50 degrees. That's all you had to do for this one, right? Okay, so I'll just give you 1 minute if you need to do your corrections. You only get a mark if you've given a statement and a reason for your exterior angle. 1 minute. Okay, class, don't forget 0635081301 is our WhatsApp line. You definitely need to make sure you get in touch. I want to know who is with us today, okay? All right, now let's talk about the concepts associated with today's lesson, one of them being congruence, right? So the term congruence refers to shapes that have the exact same shape as well as a size. It must both be there, right? We are looking at their shape and their size, okay? Okay, and then when we talk about corresponding, so it can be corresponding angles, corresponding sides, it would mean that you must have sides that are in the same position relative to the angles, to the shape being compared. I'll show you just now, okay? Remember we talked about corresponding angles earlier? What were we looking at? We're looking for angles that were on the same side of the transversal, both below the parallel lines. And do you remember those things? It's the same concept. So they must have the same position, right? So if this is our triangles, okay, let's just assume it's a right angle, even though it's a sketchy right angle, okay? So let's say I have my two triangles, okay? Which side corresponds to which in this case? So the hypotenuse, which is the longest side in the right angle, would have to correspond to the hypotenuse in the other triangle. Make sense? Okay? Don't mind the markings. I'm just showing you what we would mean when we're talking about corresponding sides. Make sense? Okay. Right. But we will keep discussing these things as we go. And now here, we are going to start off every a condition by first discovering if it is possible for that condition to exist through investigation, and then writing down the geometric reason that we would use for that condition. Make sense? Okay, like I said, today's lesson is going to entail a lot of work for us, okay? Right, but we're going to take our time and make sure we all move at the same pace and we understand what's happening. Now, the question says, are these triangles congruent? Right, how did we describe congruent triangles? We said that they'll have exactly the same shape and exactly the same size. Now, you look at the sides of all these angles, on this triangle, are they all not the same? They are. So it's the same size. The shapes, what type of triangle is this? It's a right angle triangle, right? So yes. Okay, right. So for us to say that triangles are congruent, we need to have exactly the same shape and size. Also, they must be able to fit exactly on top of each other. If I slide the first triangle onto the second triangle, it must fit directly on top of it, okay? Right, so that means that all three corresponding sides and all three corresponding angles would have to be equal for that to happen. Now, this is what we're going to do an investigation on. All right, so get ready. What I want you to do is to draw two triangles in your books that look like this, okay? Right. These triangles are not exactly drawn to scale because obviously this is a PowerPoint, but we are doing the simulation of what you would have to do in your books to get this going. So you right now are going to draw triangles that look exactly like these ones. Make sure they give you enough space, all right? And then you are going to follow the measurements that we measure on my diagrams. That way we all have the same diagrams. You see, if we were in class together, I would have just given you a printout of the diagrams, or I would have given you the textbook to do a quick little tracing sketch of these triangles. Make sense? Okay, so this is our version of it, right? Okay, so because I want you to draw these triangles, and I know some of you still have to borrow the ruler from Tabisen, I'll give you 1 minute. Quickly do that, and then we get into this. Okay, class, so the way we are going to work, I am going to place the ruler on my diagram, and then I'll zoom in so you can see the values, but I won't tell you what the value is. You are the one who's going to read it off. Remember, we all want to work, and then you're going to write that value down. Use the pencil. Please make sure you use a pencil. In case you get it wrong, then we can all have the same triangles at the end and correct our work, okay? Agreed? Cool. Right, so we are going to start off with triangle ABC. We are going to, it says here, we are going to redraw the triangles, which is what we've done, and then measure the sides and angles. We are starting off by measuring the sides, right? And then we are going to fill in their values, then measure the angles, fill in their values, then come with a conclusion. Okay? All right, so we start off with triangle ABC. I'll just zoom in for you. This is the value, right? There's your value. Do you see it? Make sure you've got it down, right? The next one, let's just get the next value. So we go to the next side. Remember, I said I won't tell you because I still want you to be the one working here. And I hope you can read a ruler. If you can't, we need change from school fees. Right, how about this one? Do you have this value? All right. We need one more side from our triangle. You keep making sure you write down those values as you see them. As soon as you have figured out the value, you write it down. Right. Do you have this side? It must definitely be bigger than 6.5. Do you see that? Okay, cool. Right, we have all three sides. So triangle ABC is complete. These are the values you should have. AC is 8.9 centimeters. AB is 6.7 centimeters, and then BC is 6.8 centimeters. Please, if you have values that are different from these ones, I'm asking you to please make sure you correct them and write down these values, okay? All right. Okay. I'll keep these values available for you as we go through the investigation, right? So don't panic. Now we need to go measure triangle EFD or DEF, all right? Okay. So you've made sure you've recorded your marks there. Now we need to measure DEF. We are going to start off with side FD, right? Now, because I want you to be able to identify the sides, I've left the letters on this chart. Are you able to see FD there? Okay. It's not 9 centimeters, that's for sure. Okay. Okay, we've got that. Then we are going to measure side DE. Right. Do you see a value? It's bigger than 6.5. Do you have it? See, I'm giving you hints. I don't want you to fail. We are doing an investigation after all. And then for EF, the side EF there, also bigger than 6.5. You've got them. Right. Well done if you got these correct. By now, I think you should have a hint of what values you should have gotten. But remember, those were the values from earlier, right? And then these are the values you should have for triangle DEF. Okay. Now, because I wanted you to make sure you got these, if you got them, I will give you 6 marks for these, all right? This is just because that means you are paying attention. Well done. All right. What does this mean? This means that we have finished the first part where it said measure the sides, okay? The next part is for us to measure the angles. What do we need to measure the angles of a triangle? We need a protractor. It's very important to also understand how to place your protractor correctly, okay? So you need to learn how to place your protractor correctly as well. That is a skill that is very important as well, okay? So here we are going to start by measuring triangle ABC again, okay? Right, we are measuring angle A. So do you need me to zoom in one more time? All right, I want to make sure that you can see. Okay, now here, let me just show you something important here. How do we measure? Which numbers do we use in this case? If you set the numbers inside, you are correct, okay? Because we are measuring in an anti-clockwise position, direction, okay? So make sure you're using these numbers, 10, 20, 30, going anti-clockwise. You've got the value. It's pretty clear. I'm just making sure everyone can see, even the ones who forgot their classes at home. Right. And then for angle B, now angle B, how do we measure angle B? We have to go in the clockwise direction, okay? We are measuring in the clockwise direction. That means you must use the values outside, the last ones, these ones, 10 here, 20, 30. Those are the values you're going to use, all right? You've got these, well done. So you've got your angle B. We need angle C, okay? Now for angle C, we are going to look at this one, all right? We are using which values? The values outside again. Do you have it? All right, okay. Did you write all 3 of these values down? this is what you should have gotten. I'll give you just 1 minute to quickly do your triangles. Some of you might even have protractors and want to just follow along. So if you have, you can take it out and maybe just even measure your own triangles and see what values you get. Okay, just 1 minute. All right, class. So far, who's getting this? Who's getting an idea of what is happening here? Right. Some of you have an idea, right? Let's see what do we do with a triangle EFD. So now we need to measure triangle EFD's angles, right? The interior angles. If you have done your 3 angles from ABC and you feel you are not sure that you've done your measurements correctly, just add all 3 of them. If you get 180 degrees, you have done it correctly. Okay, don't forget, that's why we were learning all about triangles before. This is the application you need. Okay, right, so we're going to start by measuring angle F. That's where we are. I'll zoom in for you in case you need help again. All right, there we are. Which numbers are we using? You are going in this direction, so anti-clockwise in the numbers underneath your arc there, 10, 20, 30. Those are the values you're using. Okay, I'm still not going to tell you. I know you can read this value off for yourself. All right, and then for D is pretty straightforward, isn't it? So clear. Can you see it? And please, it's not 130 degrees, just in case. Okay, right. All right, and then for angle E. Angle E, what value do we see? Well, I can tell you that it's not 100 degrees. Okay, right. In fact, it's actually less than 90 degrees. Do you see it? Okay, so because this is the last one, I will show you. The way we are going to work with this one, we have to use the values on the outside here. These 10, 20, 30. Those are the values we are using. Therefore, we go all the way up to 80, 81, 82 degrees for angle E there. All right. Okay, so in case you missed it, angle A is equal to 50 degrees. Angle B is 82 degrees. Angle C is 48 degrees. Then you've got angle F, 48 degrees. Angle E, 82 degrees. Angle D, 50 degrees. Do we all have those values? All right, please make sure you've got those values. They will come in handy. Right, so you've marked your angles. Then comes the questions you're supposed to answer. The triangles are still the same here. I've got them for you. So we start with our observations about the size. Remember, when you do an investigation, you start off with an aim and then you do your plan of how you're going to investigate, and then you come up with a conclusion. So these are observations about the sides. All right, what did we find? We found that AB is equal to DE. Did you notice that? They're both 6.7 centimeters. Right. Right. Can you notice other pairs of equal sides? I want you to write them down. You have 1 minute. All right, class, let's see which ones you should have noticed. So we know that 6.7 centimeters is for A, B, and D, E. And then we've got a 6.8 centimeters for B, C, and E, F. Okay. And we also have AC is equal to DF, and they are both equal to 8.9 centimeters. So well done if you have those correct, okay? Right. I forgot to give you marks for angles. If you got each of the angles correct, you are also on 6 marks. So you'd have 12 marks plus those 2 that I'm giving you here so far. Okay? All right, so you had 14 marks. 6 for angles, 6 for measuring the sides correctly, and 2 for being able to participate in the observations. Now, we are going to the observations about the angles. All right. In these 2 triangles, do you want to see a trick? I've already actually highlighted the equal angles for you. Notes, I've color-coded them, so if you can tell the difference between the colors, it will be helpful. But what you notice is when you name your sides, the corresponding angles will also show you which ones are equal. All right, so the letters will show you which vertices have equal angles as well in this case. So angle A is equal to angle D, all right, and that's 50 degrees. Angle B is equal to angle E at 82 degrees. And then angle C is equal to angle F. It's 48 degrees. Okay, all right. So now comes the part where we come up with a conclusion based on our investigation and our observations. In these 2 triangles, what is equal, what is not equal, you need to fill in this part. All right, so what you're going to do is to use a selection of terms or words from here, from the box, and write them to fill in the missing, the blank spaces. Okay, all right, you have 2 minutes for that. Right, so in the given triangles, the corresponding sides and corresponding angles are equal. Do you have that? This is simply from what we've just done, right? Okay. And then if all the corresponding dash of 2 triangles, which ones are we talking about? Sides are equal, then your triangles are congruent, right? Why did we choose congruent and not similar? That is because we now know that for congruent shapes, the angles and the sides have to be equal, the corresponding angles and the corresponding sides. But at the same time, we cannot use the angles as a condition for congruence. And we are going to discuss this a bit later on, why angle is not a condition we're going to use here, but we're going to use side for this condition. Okay. All right. Okay, so you'll encounter this statement again as we discuss the conditions. Don't worry if you need to go through it. So like we said, two triangles are congruent if they have the same shape and size. And we also said that that means they must be able to fit on top of each other, right? They should be able to fit on exactly on top of each other because their angles are equal and their sides are equal, right? That's what we said, right? So would we be able to do that with our two triangles? Let's see. We are sliding it over, and yes, there they are. They do fit exactly on top of each other as well. All right. So well done. We have just now worked out one of the conditions for congruence. Okay. All right. Now, do you think these triangles are congruent? What do you think? When you look at them, AB is 12 centimeters, AC is 10, BC is 11 centimeters. The same values are showing up in triangle DEF, aren't they? So are they congruent? The answer should have been yes, okay? These are almost similar to the triangles we've just worked with. All right. So if we are saying these are congruent, number one, that means if triangle ABC is congruent to EFD, what does it mean? It means the sides are equal, right? So AB must be equal to EF, right? Now, this also means that because we say they should, the congruent shapes should fit exactly on top of each other. This also goes for the sides as well, by the way, all right? So the sides should have the same length as well, okay? Then BC will be equal to FD or DF, okay? So I'll call it FD. Then AC will be equal to ED. Right, so there you go. You see, you've got all your sides. They are perfectly able to fit on top of each other there. What's important here is to keep note of the order in which the statement for congruence is given, this part. If this is given in the question, it's already in the correct order. But if you have to come up with it, make sure you are writing it in such a way that you can read off the corresponding sides or the equal sides from the statement. I will go through that with you as well. Okay, but you should notice that if I say AB here, let me just clear this. All right, so for your sides, look here, AB is equal to EF. Is that not what we have? Your eyebrow, right? And then you've got BC, your second eyebrow, is equal to FD. There you go. Right, and then you've got your smile. AC is equal to ET. Do you see that? So you should be able to pick up that about your sides from your diagram. Eyebrow, eyebrow, smile. Okay. All right, so order is very important. Now you understand what we mean by that, right? Your corresponding vertices between the two triangles must appear in that same position in your notation as well. Okay, now this is the symbol for congruence. I know some of you might confuse congruence with a similarity because, when you see the symbol, you don't know whether they mean congruence or similarity. For you to remember that, just write down the word congruence. I hope you can spell it correctly. And you look at the E. The arms of your E must remind you of the symbol for congruence. Do you see it? Okay, so that's a good trick. That way you'll be able to differentiate between congruence and similarity. Similarity, we use the eyes. I will show you that in the next lesson as well. Okay. All right, so now I want us to dig a little bit deeper when it comes to how do we decide that these triangles are congruent. Okay, I want us to work from one side, right? If we have 11 centimeters for one of the triangles, right? So we measure 11 centimeters. We measure a triangle for 11 centimeters. By the way, if you have instruments, you can do this, but this is just a simple demonstration on constructions. I don't expect you to do the construction. I just want you to understand the concept, okay? Right, so we measure 11 centimeters, and then for the sake of being able to have reference points, we'll call the vertex X and Y, okay? So we've labeled our line XY. Right, then we measure 12 centimeters. By the way, this is not a complete 12 centimeters. Remember, my diagrams are not drawn to scale. This is a simple simulation. Right, so you've got 12 centimeters going up. Why? This is not a drawing. This is where you would place your compass, right? You'd measure 12, you'd place your ruler, then measure 12 centimeters. That would be the radius of your circle if you remember constructions. Then you need to draw an arc that measures the front at the 12 centimeter line, right? And then you measure again. We want 10 centimeters on the other side, so we need to draw an arc as well for that side to show the radius of the 10 centimeter circle, of the circle that has a 10 centimeter radius. So you'd have two arcs, and then you have this point where the arcs meet. Okay, that point we'll call it Z for now, right? So this means that at that point, that's where you would actually have your two lines that you would draw from point X and from point Y. They would meet at point Z, right? So what does this tell you? If you draw lines or extend or draw lines from the ends of one line that you know what its length is. So if you know that this line is 10 centimeters, if you draw two lines from the ends of that line, there's only one point where the two lines can meet. Otherwise, they'll look like the two lines I had that were just wide, so they could be on any other point of the circle, right? But for them to form a triangle, there's only one point where they can meet. Make sense? Okay. All right. So the first condition is simply based on our understanding of that if we draw two lines or two sides based on the length of one of the sides, or by knowing one of the sides, there's only one point those sides will meet. Therefore, if three sides of one triangle are equal in length to the three sides of another triangle, then the two triangles will be congruent, right? And this is still that investigation you worked on, your side, side, side. Make sure you write this down. Okay, you need this. Condition one, if three sides of one triangle are equal in length to the three sides of another triangle, then the two triangles are congruent. You can either write it in words or write down the condition as side, 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 and leave it at that. You've got it? Okay? Right, do you think these two triangles are congruent? What do you think? All right, let's see if it makes sense. The answer is yes, they are congruent, right? Because when you go from the concept we've worked on already, in this case, you even have an extra side given, the second side, 12 centimeters. You notice these are the same triangles we worked with. We are missing only one side. Okay, but now we've added an angle that is between them. Okay, all right, so let's talk about it from this point. It's the same triangles again. Don't mind the color change. If I add this dead side here, would these triangles be congruent? And the answer here should still be yes, right? We did a construction earlier. It's the same concept, right? The answer would still be yes, okay? So that means having a side, an angle between the two sides and another side. So having a side, and an angle between the two sides is enough to prove that triangles are congruent. Agreed? Okay. Now, how do we write this in mathematical language? We would say that if we know that we've got one length, right, a length like 11 centimeters, and then we know also the position of the other two sides, right, or the position of the second side. There's only one other side. There's only one possible solution for the third side. Think about it from this, okay? If we said use my fingers. If we said these two are the arms of your triangle, the first two sides of your triangle, where will the third side be? The third side can only be here. Agreed? Like, that is exactly where it's going to be. If it's in any other position, that shape will no longer be a triangle. Make sense? That is what we mean here. Okay. All right. So that brings us to the second condition. It says if two sides and an included angle are equal in length to two sides and an included angle in another triangle, the two triangles are congruent, and you have side, angle, side. The angle has to be included. It must be between the sides. Okay? So basically, if you think about it, if you look at the word, it says, right? You know, sessiness comes from within. So your angle must come from within the sides. Make sense? Okay, cool. Right. If you have questions, 0635081301. Okay? Make sure you send us your messages. Right. Next, we look at these ones. Are they congruent? What do you think? For this one, I'm not going to tell you yes or no. I want you to think about it, and then we are going to do our investigation again and see if it's possible. Okay. Right. So we are working with two angles here. Do you notice we have two angles on the side, right? Now we want to understand if this is possible. The side is 6 centimeters long. There you go. So we measure 6 centimeters. Then now, because we have two angles, we want to measure the angles. Right. We are going to start off by measuring 60 degrees. Okay. Now you know how to place your protractor, right? If you have these tools, please, you are welcome to participate in what I'm doing here. So there's my 60 degrees there. So I measure my 60-degree angle and I draw my line, right? I don't know what the length is, so I just extended it all the way. Okay, 60 degrees, right? And then I come to the point Q here. I need to draw another line. This you would do using the concept we've discussed before, where you draw your arcs and all that, okay? I measure my 80 degrees, and then where do they meet? They meet at that point there. We'll call it R for now. So we have a triangle PQR, right? Do you see that if I know the angles here, there's only one point for my lines to meet. Do you see that? So having two angles and one side is enough to prove that triangles will be congruent, right? So sides that are made using angles at the end of a known length will only meet in one place, right? In that case, this means these two triangles can be said to be congruent, right? That brings us to the third condition for congruence. If the two angles and one side in a corresponding position in both triangles are equal, then the triangles are congruent, right? Now, the pleasure in this one is that there are different versions of it, right? The side doesn't have to be between the angles. It can be angle, angle, side, right? You can even have your famous A line there, right? So those are other options of that one, okay? And I think by now you can actually prove this yourself. You will always just measure some two angles and figure out how you would prove this. I think you should challenge yourself to see if you can come up with the proof for those as well. Okay. All right. Then you have that condition. I hope you do. The next one, are these ones congruent? Let's look at them. We're given two sides, and are we given anything else? Yes, we're given an angle. We're given two sides and an angle. What is this angle? It's a right angle. And that means that one of the sides has a name. What is it called? A hypotenuse, right? Now, can we say that these two triangles are congruent? Definitely, these triangles are congruent, right? Think about it. Because these are right angle triangles, you know that according to Pythagoras, your right angle triangle will have a specific proportion. Hence, we are able to use the hypotenuse squared is equal to the sum of the two sides squared, right? Okay. That's the proportion. So your hypotenuse will always be the longest side, and it will always be opposite your right angle. Okay, but also because you can use Pythagoras to find the third side, and in this case, your two sides here, your hypotenuse and one of the sides, which you will call the adjacent side or the opposite side, are equal. The third side will only have one length. Make sense? So you'll be able to calculate the third side, and you could prove, because of that, you have side, because you would be able to calculate the third side. Agreed? If you know two sides of a right angle, you should be able to calculate the third side. We've got that. Okay? Okay. Right. Now, why can't we use side angle side as a condition for this right angle triangle? Do you know? That's because the right angle will never be between the two given sides, okay? Especially, it will never be between the side and the hypotenuse specifically. We need to be specific about the hypotenuse part, okay? The right angle will always be opposite the hypotenuse. Therefore, the only time you can use side angle side is if you are given this, maybe this 15 centimeters was here, and you didn't know what the hypotenuse was. That would work. Make sense? If you didn't know what the hypotenuse was, let's say it wasn't there, then you could use side angle side, because it would be side angle side. But in this case, you cannot use a side angle side. So what do we use? We use right angle hypotenuse side. What do you need to use? Right angle hypotenuse side. You make sure you've got all of those, okay? All right, so you might have the corresponding hypotenuse equal, and the corresponding side that is equal, and also right angles in your triangle, okay? So it's not always that your right angle triangles will be congruent because of right angle hypotenuse side, but do check if you are given the hypotenuse, right? If you are not given the hypotenuse, then you would use either side, okay? Or you'd use side angle side, okay? Cool. The next one. Now, this is a good question because this is similar to what we started with earlier when we started our investigation, where we measured all the angles and all the sides, right? Okay, and the corresponding angles were equal. But I said to you, we cannot use that as a condition for congruence at the moment. And why is that? Why do you think that would be? Well, let's look at these two triangles here, okay? It's possible to have a triangle that is 60 degrees, 60, 60, 60, all the sides, but only to all the angles are 60, pardon, but only to find that the sides maybe are 2 centimeters each. They have to be the same, isn't it? Because it is an equilateral triangle after all, right? So it's possible to have an equilateral triangle where the sides are all 2 centimeters each. And mind you, it's not drawn to scale, all right? And then maybe you'd have this one with sides that are 10 centimeters. Do you see that? Do you get why we can't use the angles? Okay, right, so you could have a very large triangle with the same angles, or a very small triangle with these same angles. Therefore, the answer here will be no. These triangles do not represent a condition for congruence, okay? Right. So because we said it's possible for them to have equal angles, but have unequal corresponding sides, right? Therefore, A or angle is not a condition for congruence, all right? Do make sure you've got this. I don't want you making that mistake, all right? Okay. Right, so here I have two triangles for you, and I'm telling you they are congruent. It's triangle ABC and triangle XYZ, okay? So this is just to help you with notation, all right? This is just to help you with notation one more time. We've done a similar example at the beginning, but I just want you to be able to do the notation again. All right, so we are going to start. So if you have two triangles that are congruent, you know that your corresponding angles must be equal. So angle A will be equal to angle X. And in this case, it's actually indicated by the symbols around the angles. Angle B will be equal to angle Y, and angle C will be equal to angle Z, right? Okay, and then for your sides, your corresponding sides will also be equal. Now with your corresponding sides, you can still use your eyebrow smile concept. Let's use, I like green eyebrows. The idea of having a green eyebrows is fun. So that would mean AB will be equal to XY, right? See, and then you can have BC equal to YZ. I hope that makes sense. Okay, and then we need a third side. What's our third side? Our third side will be AC equal to XY. Eyebrow smile. All right, so here's the hint. If you are told that triangles are congruent, or if you are asked to prove that triangle ABC is congruent to triangle XYZ in this format, it's already in the correct order for you, unless if you prove it in a different way. But what you want to do is to make sure that the equal angles are in corresponding positions as well when you write down the names of your triangles. Okay, all right. Now for this activity, I would have liked for you to do it, but we are definitely running out of time. So what I'm going to do is I'm going to give you just 2 minutes to copy it down. You are going to practice it as part of your homework, and then after this I will give you another slide again for homework you are going to work today. Right, so 2 minutes for this one. Okay, class, so did you copy this? You've got it. All right, I just want to skip to your homework. Okay, I'm going to show you your homework. That will also mean that you will need to do both the activity and the homework. All right, make sure you've got all of them, because we only did the investigation, but there are skills we need to apply our understanding of that investigation to. So this is the homework. It is also a type of assessment question. Now for this one, you'll just have 1 minute. You are going to just take a screenshot. Agreed? Screenshot or a picture quickly, 1 minute. Right, class. I do not have any questions, but I did get a few inputs, and thank you so much for the people who are joining us for the first time today. You're welcome. We are here every Wednesday. Do join us at 9 a.m. All right. Okay, so if you have questions, save our number for the next time we have a lesson on a Wednesday, 0635081301. And make sure you send your questions as we go through the lesson. That way I can answer them in real time. That way you are not stuck on a question when you could have had help. Okay, all right. Now, let's talk about the conditions we discussed. First condition, side, side, side. You must have 3 pairs of equal sides. 3 pairs of corresponding sides equal, and then you must have a side angle side. It must be 2 pairs of sides that are equal and a pair of included angles. The angles must be between the sides. That's very important because it's possible to have an angle in 2 sides but not have that angle between the sides, okay? And if that's the case, you cannot say that those are congruent, okay? Because one of the sides could be longer depending on how big the angle between the sides is. Make sense? Okay. All right. Then angle, side. Any 2 angles, you need 2 pairs of equal angles and a pair of corresponding sides equal. This one we use if we are given a hypotenuse, a side, and a right angle. All right, so here, if you're given one side, hypotenuse, and a right angle, and they correspond and are equal to the next triangle, then you use RHS, right angle, hypotenuse, side. Some of you actually use 90 degrees hypotenuse side. That is also okay. All right, so do focus on what you have learned as well in class. Okay, all right. Thank you so much for joining us today. This lesson is proudly brought to you by the Gauteng Department of Education. Before I forget, next week we are going to be looking at a similarity. We are doing a similar investigation. So now that you know what to expect, bring your tools. I'll see you then.